Which moon is your favorite? We'll help you decide on this week's Planetary Radio Book Club edition. Welcome, readers of books about our solar system and the cosmos beyond. I'm Mat Kaplan, Senior Communications Advisor for the Planetary Society and former host of Planetary Radio. We're keeping it in the family this time as we welcome our beloved colleague, Kate Howells. It's Kate's new book, her second, that we made our October 2025 selection, and it's mostly what we'll talk about today. That book is titled MOONS, The Mysteries and Marvels of Our Solar System. You can watch the video of our conversation on the Planetary Society website. We've got that link on this episode's page at planetary.org/radio. That said, we can dive right into the live conversation I had with Kate in the Planetary Society member community. Hey everybody, we're back. It's the Planetary Society Book Club, welcoming you once again. Here we are with our special guest for this evening, someone who should be familiar to at least some of you, Kate Howells, my wonderful colleague, science communicator extraordinaire, is the Society's public education specialist. That title really only begins to describe all that she does and has done for you folks, our members, and for others. Do you read our excellent newsletter, The Downlink? Well, that's Kate. She puts that together every week. I'm especially impressed, though, by her service as the editor of the Planetary Report, our award-winning print and digital magazine. I also want to tell you that I really believe that you very admirably hold up a tradition, the creation of the magazine, that goes back to the very beginning of the Society and its very first editor, Charlene Anderson, our associate director of the Society, long retired now, but she is also the person who was my first boss at the Planetary Society, and I can tell you, you have reason to be very proud to be continuing that tradition, Kate.
Thank you.
So let's talk about her books, because it is plural. MOONS is not Kate's first book. I can't say her first book's full title without having to change our status as a kid-friendly service. So use your imagination, as I call it. Space is cool as a four-letter word for an intimate activity. And it really is cool. Yeah, space, but the book is amazing. It's a graphical wonder, full of amazing art and very entertaining text, and just chock full of that old PB&J, that passion, beauty, and joy for space exploration and science that all of us love. Parents, you may want to wait a few years before giving it to your space-crazed 6-year-old. But none of that is true for this book, which is the one that we will be talking about over the next hour or so. It is called MOONS, The Mysteries and Marvels of Our Solar System, and it has been created by my colleague, Kate Howells. Kate, it is great fun. Thank you so much for doing this and for joining us this evening.
Thank you. It's truly an honor to be the book club author and not just behind the scenes sharing out the book club links and promoting it and following along with your conversations with others.
Well, it's well-deserved, of course. What led to creating this great book?
The moons of the solar system were one of the first things that I learned about that really got my imagination going. And I was actually reading Carl Sagan's Cosmos that did it, because he describes the Voyager mission in all its glory. But one of the things that really struck me was what Voyager discovered about the moons of Jupiter and Saturn. And I read this before I was in the space biz. I hadn't really studied space beyond elementary school. And you don't learn about the moons other than Earth's moon if you're not really learning more than what's in just average school curriculums. And so this was brand new information to me, and I was blown away. I saw photos from Voyager of Io with all of its volcanoes. I was like, what? This is so cool. This is so much cooler than, I mean, the planets are great, don't get me wrong, but the moons really were just this amazing discovery. And I thought, a lot of people probably don't know about these incredibly cool worlds and how much promise they have for the search for life, but also just for understanding the diversity of planetary bodies that is out there in the universe. So I'd always kind of had this idea that a book about moons could be the perfect sort of low-hanging fruit for people who don't know a lot about space already. And I always try to write in a style that's accessible and aimed towards people who maybe are a little wary of delving into a scientific topic. I myself was not a big science person until my early 20s, really. So I understand that perspective of thinking like, oh, you know, math is hard and I didn't do well in chemistry, so like maybe I shouldn't voyage into scientific topics. But so my mission now is to kind of change people's minds who might think that way as well. And I think moons are a great way to do that.
I couldn't agree more, and you're living proof that you don't have to start when you're 6 or 7 as a space nerd or space geek. You open the book with this great anecdote, and it's 2 shopping channel hosts who are kind of clueless. Tell us a little bit about that. Talk about that.
Yeah, it's this hilarious clip that I saw on YouTube years ago, and it's shopping channel hosts, and they're talking about a blouse that's it's kind of got a pattern like this. It's sort of like, and they say it kind of looks like the planet Moon from a great distance. And the other one says, the moon's not a planet, it's a star. And they say, no, the moon's not a star. What are you talking about? It's a planet. And then they have this back and forth where they're arguing, and they're like, well, then what, but the sun is a star. What's isn't the moon like the sun? And someone says, no, darling, the moon is totally a planet. And then they have their producer Google it, and the producer gives them this definition of the moon is a moon. The moon is a natural satellite, and they're just more lost than they were before. And they kind of continue back and forth, and then they eventually just go back to talking about the clothes. And I think it's such a great encapsulation of a lot of people's very benign ignorance. Like, a lot of people don't know what the moon is. Our moon, the moon that you see in the sky, and they think there's the night sun, or, you know, it's equivalent. And I think it's so remarkable, and there's no disrespect intended towards anybody who doesn't know this stuff already, because again, you only know what you know, and you don't necessarily get opportunities to learn everything. So it's not, no shade, but it's funny to me that there's this great example of people just having no clue what the moon is. So that's my starting point of like, all right, let's talk about what the moon is. Let's talk about what other moons are.
The vast majority of all the humans who ever lived didn't know what was really going on with the moon, didn't even know that it wasn't shining from its own light, that it was reflected from the sun. So anybody out there who may still have a misunderstanding about our big natural satellite, they're in good company. Of course, our Absolutely. Moon, it is one of the major ones that you talk about in the book, but there are lots of others. You have your also-rans, your honorable mentions at the end of the book. But how did you decide among the now hundreds of moons and more every year across our solar system, how did you decide which ones to spend give the most attention to?
Well, it sort of came down to which ones have the most going on, and that tends to be the bigger moons. They tend to have more interesting geology, and some of them have an atmosphere or a magnetic field, and so there's kind of more to talk about with the bigger moons. But then, especially in the honorable mentions, you get the smaller ones that are interesting for some reason or another, like Pan, the little dumpling moon, for example. And I think the smallest moons that I give a full chapter to are Mars's moons, because again, they're kind of interesting in their own right because of how they formed and how they might get disintegrated into a ring system in the future, and how they might factor into Mars exploration. And then you kind of get the chance to talk a little bit about Mars and why we want to explore there. Yeah, it sort of came down to which ones had the most material really available about them. That is to say, I'm sure there are a lot of moon researchers who will read my book and say, wow, you missed so much cool stuff about whatever XYZ tiny little moon. And I'll have to do a sequel.
Oh, there's an idea. Hey, folks, tell us your favorite moons, whether they're in the book or not. Add those to the chat, and we will be sure to talk about those. I think you made great choices. I want to start talking about some of these. And we can start right where you do in the book, which is one of my two favorite moons across the solar system. You feature both of them in the longer essays that you did. Is Jupiter's Io also at or near the top of your list?
Yes. Io was my favorite moon for a long time because it's shocking. It's unlike any other planetary body that we know of, and it's terrifying and it's intense, and it was one of the first moons that I learned about where I really thought, holy smokes, there's a lot going on out there that's really wild. For those who don't know, Io is it's the most volcanically active body in the solar system. So it has hundreds of volcanoes across its surface, erupting basically nonstop, huge lakes of lava, eruptions of lava, but also gases that spew hundreds of kilometers into space. It is a chaotic nightmare of a place. And it's just completely awesome. Yeah, it's no longer my top favorite, but it was for a long time.
And I have always loved it. I mean, since we learned its true nature, which started back in the Galileo days, when Galileo was orbiting Jupiter and certainly was vastly amplified by Voyager. Now, for a layperson, I know a fair amount about what's going on across the solar system, but the book still had a whole bunch of really interesting facts that were kind of stunning to me. And one of the ones in this chapter about Io is that with its more than 400 volcanoes, you said that it's more than 100 times more lava than all of our earthbound volcanoes combined, which just blows me away.
Yeah, it is, again, it's just shocking. Everything, and I don't have a great memory for numbers, so I won't try to quote specific numbers that I mentioned in the book here right now, because I'll get them wrong. But the numbers on Io are crazy, where, the volume of lava, the heat of the lava, how high up it all shoots out of the volcanoes, it's way beyond what we see on Earth. And it has a lot to do with the fact that Io is just so much smaller. So, for example, with like lava flows that can go much, much further and shoot much higher, there isn't the same like gravitational pull slowing everything down that we have on Earth, because Earth is just like so much enormously bigger than Io. And so you get these different dynamics because of the different nature of the celestial body itself. And that leads to these really wild phenomena that you see on Io, which is, again, it's just really cool. You learn these little facts and then you learn about why they happen, and that in itself is kind of cool and surprising. And I will say I also didn't know everything that I wrote in this book until I was researching it. I picked moons and I chose specific bodies because of what I already knew, but then in researching, I just discovered so much more, and it was such an enriching process for me personally to just dive deeper and deeper into all of these different bodies.
Yeah, talk about stuff shooting up. I also learned from the book that, the lava goes pretty high, but the gas coming out of these volcanoes, 500 kilometers beyond the surface, which is mind-blowing.
It's bonkers. And you think about, thinking about being on the surface of another celestial body is always interesting. Trying to picture yourself there. And Io's a great one. You have to just assume that you're very well protected somehow from the extreme conditions. Yeah. But if you imagine, like, the International Space Station orbits Earth at what, like 100 kilometers above the surface?
More than that. I think it's, oh God, somebody can correct us. It's at least 200 kilometers and might be 400.
Okay, so let's say it's 200. Mm-hmm. Geysers of gas shooting twice that high from the surface. You can't imagine what that would actually look like to be standing next to one of these geysers, looking at it shooting that high, and then seeing Jupiter in the background. It's great fodder for the imagination.
Which is a great lead-in to something else that I wanted to talk about anyway, because here and there in the book is richly illustrated far beyond these original illustrations or paintings. But there are these full-page illustrations by the artist Gordon Auld.
Yes.
Did I pronounce it correctly? The one for Io, here it is. is right in line with what you were just talking about. This is nuts. I mean, this is one suicidal astronaut. It reminds me of that epic battle, episode 3 of Star Wars, Obi-Wan and Anakin, rolling around a few inches from lava. And then, of course, Anakin ends up in it. Except in your book, it's this astronaut risking life and limb for science.
Yes.
Which is pretty cool. I mean, tell us a little bit about Gordon and how he ended up doing these great illustrations. We got one more that we'll show a little bit later.
Gord is a good friend of mine. We've been friends since high school, actually, and he's just a really talented artist. And as long as I've known him, he's enjoyed drawing spacey, sciencey kind of things. So I actually worked with him on the Space is Cool book, and he did some illustrations for that. And then he's done illustrations for the Planetary Society as well. And he's just great to work with, and he's a good friend that I see all the time. So I'll just text him, "Hey, Gord, you wanna draw Io?" And he's like, "Sure, yeah." And yeah, the reason that I wanted to have illustrations and not just real space images is that I did want to try to capture things that we know to be true, but that we don't have direct images of. So things like being on the surface of Titan and what that might look like, we can kind of piece together an imagined view based on the science we know. And of course, he takes artistic liberties, and that's all fine. Nobody should expect this to be perfectly accurate, but for all of the illustrations, it's to try to give you a glimpse into what you could imagine it would be like to be there. So almost all of them have an astronaut present somewhere in the illustration to kind of just, give you a sense of the imagined view that you could have if somehow you were able to be there.
Yeah, and the human experience of it. And it also just the scale that it adds to these fanciful images. Before we move out one moon and one chapter, I'm going to read some stuff from other members that is coming in. John says, Saturn's moon Hyperion's exotic appearance has always fascinated me. It looks freezer burned. I think it's one of your also-rans. Philip says, his favorite moon is Europa, which is exactly where we're going next, Philip. So good timing. He says he loves how Enceladus has fountains like Las Vegas. Yeah, I've been in front of the Bellagio Hotel in Vegas, Philip, and it ain't the same. I mean, I'd love someday to be out there looking at those.
Vegas wishes it had the fountains of Enceladus.
So if we go out and move out that one orbit also at Jupiter, we do end up at Europa. I wonder, Kate, what your thoughts are about the visitor that is on its way there right now, Europa Clipper, which is, fingers crossed, going to get there in 2030.
Oh, yes. Very exciting. I mean, I have not been in the biz as long as you have, Matt, but I've been there long enough now to remember the origins of missions like Europa Clipper, where they say, oh, we want to send a mission to Europa. And then the Planetary Society advocates so hard to make it happen. And then it gets approved, and then it gets built, and then it launches, and now it's on its way. And it's wild when you, like, the timescales that these missions take to go from conception to launch, but then the travel time is so huge as well. You have to be very patient to be interested in space exploration, but it's thrilling to know that it's on its way. I'm very optimistic that Europa Clipper will make discoveries that prompt new questions. I don't necessarily think, it's going to find, the conclusive sign of life, because I think the science community is very cautious. And so what I hope it will find is something like what Perseverance found on Mars with the Chaieva Falls sample, where you see something that's so tantalizing and intriguing that it prompts further study. So more missions that have the tools to do more, or something like a Europa sample return. I'm so excited for it to push the science forward.
I'm really hoping that Europa Clipper outperforms even what its team says and finds some just ridiculously long organic molecules. And then really, how could we avoid going back and
exactly
digging a little bit? There's a key line that you use in this chapter about Europa, and we see it all the time. We hear it all the time. It applies to pretty much all of science. It starts, as is so often the case with space exploration, the little bit we've learned about Europa has opened up many more questions, which is exactly what we're talking about. I mean, my God, if we find those molecules, or if we go down to the surface and find some fossil, wow. I mean, how you know that we're going to want to explore this brand new ecosystem, this new place where life has found a toehold.
Absolutely. And yeah, we'll want to go off to the other icy moons as well and see what secrets they might be hiding. Because there's this whole collection of icy bodies that could potentially have the conditions for life under their surfaces, Enceladus being another key one. And, imagine if we find something really tantalizing at Europa, what might we find if we visit some of these other moons up close and study them?
Yeah, I got to go to Enceladus as well.
Mm-hmm.
Another one of those great illustrations by Gordon is this one. And here is a diver under the, 30 or so kilometers of ice swimming around. Did you notice? I wonder if you talked with Gordon about this. As he swims, he seems to be missing. There are a few little glowing spots, sort of orangish spots behind him, which I think are worthy of investigation. And he ought to be swimming over that way.
But imagine what he's swimming towards, or she is, or they, that's just out of view, that maybe there's something even more tantalizing just ahead.
Exactly right. Yeah, right. Maybe it's a Europan under the water beckoning him to come on over. All right. We'll keep heading out because our time here is limited, of course. But we'll stay in the Galilean moons, get out past Ganymede, and we reach Callisto, the last of the Galilean moons. I didn't remember, if I knew, that it has what we think, you mentioned in the book, the oldest surface in the solar system. And of course, when a surface is that old, it can teach us a lot.
Yeah. Callisto, I always think of as almost like a disco ball because it's so peppered with impact craters that it has this sort of, disco ball-ish appearance. And again, it's just this diversity that you see, even in just the Jovian system, just the moons around Jupiter. You've got Io, which is just this rock and lava hellscape, just completely insane. And then you have Europa, which is this serene, smooth, I think the smoothest surface in the solar system, or one of them. I think
you're right.
And then Callisto is this pockmarked, crazy place. So even within such a small area, you have, huge, but relatively small, you have so much diversity. And that is one of my favorite things about learning about the moons of the solar system, is just seeing how many different types of world there can be, even just in our solar system.
Absolutely. I think it's one of the greatest discoveries that we've made. Because, there was a point when they thought, okay, they're all going to look like our moon. No. And you can even extend it out to Pluto, which is moon-sized. And look what the surprise that we got there when New Horizons made its flyby.
I dare you to find a boring celestial body. I don't think that they exist.
I'm going to read some more messages in the chat window from our members who have joined us live. Mike quotes, this is very appropriate. Mike says, quoting Arthur C. Clarke, "All these worlds are yours except Europa. Attempt no landings there." Of course, from the classic 2010, Arthur C. Clarke gave us the sequel to 2001. Sorry, Arthur, Space Child, we're headed your way. Adrian says the International Space Station orbits Earth at an altitude, okay, I was almost right, between approximately 413 and 422 kilometers. For some reason, 400 sounded right to me. So there you go.
Well, I said, my memory for numbers is astonishingly poor, so I apologize.
It's like my memory for names. Philip, who we heard from earlier, was just complimenting the illustration, said beautiful illustration. Adrian came back and said the radiation at Io would kill him, your suicidal astronaut. In short order, radiation flux is 3,600 rem per day. That's lethal to humans within minutes, which of course is why everything that goes out and spends any time in the vicinity of Jupiter has to be very carefully shielded. Thank God Europa Clipper has most of its electronics inside that vault, that very thick vault. And we know, because Juno used the same system and it's still going strong, that it's going to, well, we hope it'll be just fine, because we sure want to get those results. All right, now we can move back out. Let's see. Let's go out to Saturn. Jump out one big world to another tiny world, Enceladus. Tiny but full of surprises, isn't it?
Absolutely. This is another icy moon with a subsurface ocean that shows all the signs of being very friendly to life and extremely tantalizing because of its enormous geysers that shoot out of its south pole, where you could conceivably fly through a plume and see what you get. And it's a lot more active, the geysers, than Europa. So part of me is like, oh, can't we just redirect Europa Clipper off to
I've had the same thought, yeah.
Yeah, but we'll just have to send another mission. So, but yeah, another just beautiful and fascinating place that has such intrigue, the questions that we could answer if we were able to just get there. And it's just a shame that all these places are so far away and that it takes so much work and so much money and effort and time to get there. Because otherwise, I mean, if we lived in a different world, perhaps we would have probes out at all of these places already. But I would definitely put Enceladus at the top of my list, even though there are other places that I think are maybe more interesting in other ways. But in terms of the search for life, which is just such a huge driver, such an important endeavor, I think Enceladus is tippy top of the list.
Yeah, I couldn't agree more. Like you and so many people out there, all our members, at least we had Cassini-Huygens. And I know, you and so many have a special fondness for that mission. I certainly do. That it explored Saturn and its rings and moons, and the mission ended. It's hard to believe it's been 8 years already, just over 8 years. You talk about the discovery by Cassini of those wonderful plumes, and how the team figured out how to learn more about them, where they actually repurposed an instrument that wasn't designed to tell us about the plumes, right?
Yeah. I mean, half of what I love about space exploration is just the human ingenuity.
And how?
Like the worlds that we're studying are really cool, but the things that humans achieve. And to go back to my sort of origin story of reading Cosmos and being completely enraptured, a big part of that for me was learning about the Voyager missions and like how the humans were able to, calculate these trajectories and send these spacecraft off to do all this exploration, and that they're still functioning decades later. I mean, that really blew my mind, and it's still to this day the ability of scientists and engineers and technicians, the people working behind missions, what they can do, they can juice these missions for so much more than you ever would have thought possible. And I just think that that's so impressive and cool and worth celebrating.
Absolutely. And it has been almost the rule across all of these successful planetary science missions across the solar system. All right, we got to keep moving out there, heading out in the solar system. You surprised me. You visit Neptune, Neptune's moon Triton. I thought we'd stick around at Saturn. Thank goodness I was relieved when you took us back to Titan a few pages later, because it's my other favorite moon. It's hard to choose, though. But Triton, right? Kind of crazy place. First
of all, beautiful. One of the most aesthetically pleasing moons, I would say. It looks just like this, like a snow cone or an Easter like ice cream cake or something. It's beautiful, and it's another place that we've barely studied. It was Voyager 1 or 2 numbers that flew past. And like we just got this quick flyby, and what we learned again just brought up so many questions that we just need answers to. But when are we ever going to head back there? I know that there are missions on the table to head back out into the outer solar system, but yeah, Triton is so fascinating. The idea that it might be this like a captured planet, just fascinating and beautiful. love Triton.
And I know China is at least talking about a mission to Neptune. Of course, the farther out you go, the longer it takes to get there. So we're talking about stuff that is years away, even assuming that we reach a launch. But we know so many people in the planetary science community who have been lobbying for decades to head back out there and add to that very brief flyby we had from Voyager. There is an area, a section of Triton, which is one of the things that makes it so interesting. And you probably know the one I'm about to talk about. It's the cantaloupe terrain, which you have a good image of in the book.
Yeah, I mean, again, I love scientists. I love that they see something that looks a bit like cantaloupe, and now it's called cantaloupe terrain.
Very scientific name.
Yeah, when you're discovering things that no one else has ever seen before, you get the privilege of naming it whatever you want. And I think space scientists especially have a knack for creative and kind of charming names, like even just thinking about the Big Bang, that we call it the Big Bang. I mean, it's wonderful. So yeah, cantaloupe terrain as well as one of those. And yeah, it's this sort of intriguing thing that we just need to learn more about.
That's my Planetary Society colleague, Kate Howells. Many more moons await us after this brief break.
Greetings, Bill Nye here, CEO of the Planetary Society. We are a community of people dedicated to the scientific exploration of space. We're explorers dedicated to making the future better for all humankind. Now, as the world's largest independent space organization, we are rallying public support for space exploration, making sure that there is real funding, especially for NASA science. And we've had some success during this challenging year. But along with advocacy, we have our STEP initiative and our Neo Shoemaker grants. So please support us. We want to finish 2025 strong and keep that momentum going into 2026. So check us out at planetary.org/planetaryfund today. Thank you.
The next chapter, you take us back inward in the solar system to our own moon, the one that is the moon with a capital M, unless you want to call it Luna, like a lot of science fiction people do. I'd read about how most scientists now believe, there's still some question about this, that it was formed after this tremendous impact on the primordial Earth. But I was kind of shocked to read in your book that the moon may have come together very, very quickly. Yeah.
I will say right off the bat that working on the chapter on Earth's moon was the most eye-opening, because I knew some things about the moon, but I always thought it was kind of a boring moon compared to, explosive Io or tantalizing Enceladus. But Earth's moon is super fascinating, and I am really glad to have done this research and developed this appreciation, because now I can look up in the sky and see it and think, oh, that was covered in volcanoes for years. Because it was formed by this impact, they think, between a protoplanet about the size of Mars and sort of pre-Earth. And the debris kicked up by that impact coalesced in a matter of potentially even less time. And this created so much heat that the moon was just this molten ball of lava for millions of years.
Millions and millions, many millions.
And then now when you look up at the moon and you see the sort of dark splotches, that those are volcanic basins, and because the moon was covered in active volcanoes for millions of years, right up until the timeline is like a little bit close. And I've talked to Bruce Betts, our chief scientist, about this, because the moon was volcanically active until right about the same time that the dinosaurs started to rule the Earth. And there's questions about, how active was it, and, how many dinosaurs were there, but there is evidence of a little bit of overlap. And I love the idea of dinosaurs looking up and seeing volcanoes exploding on the moon. But anyway, it just has the moon has this incredible history. I've written about it for the Planetary Report as well. There was so much more going on than you ever would have guessed. You always just think of it as this sort of stable inert body, but it had a lot going on, and it still has a lot going on. There are still really interesting places on the moon, like the lava tubes where lava once flowed and then rock formed around it, and then the lava drained out, and there are these tubes that could fit entire cities inside them. And compared to lava tubes on Earth that never get much bigger than like your average sort of underground tunnel for vehicles, it's just so interesting. And again, it's just such great fodder for the imagination.
Wouldn't you like to walk around in one of those lava tubes with an appropriate spacesuit? I mean, and of course, maybe someday there will be a city or at least a settlement or an outpost in one of those, because they provide some protection from the radiation. So yes. I know it's been talked about.
We have to just stop cutting NASA's funding, and we will eventually get there.
Start, yeah, right, yeah. Absolutely. As a side note, you have sidebars in the book here and there. You address moon landing conspiracies in one of these sidebars, which somehow continue even as we get photos back from orbit looking down at the descent stages of the Apollo landers and tracks left by the Apollo moon buggies. It makes me nuts. And our friend Phil Plait, the bad astronomer, just today in his newsletter put out a piece, his blog, about Kim Kardashian, apparently now. I haven't read it yet, but apparently she's pushing the moon conspiracy. It just drives me crazy.
You know, I think it's this fairly common ignorance. Like, ignorance sounds like such a judgmental word, but I genuinely do feel like a lot of people just don't get opportunities to learn about all the things that we get to learn about. And if you don't even really know what a moon is, of course you might believe that the moon landings were a hoax. I think it's one of those things where as soon as you actually learn about what's going on, you ought to see that it definitely happened. And we have rocks, we have lunar rocks here on Earth that the astronauts brought back and that we're studying. And the idea that there's this massive conspiracy that goes all the way down to, grad students working on research on these samples, and that, they're in on it too. And the idea that many people could keep this big secret is honestly putting a lot of faith in humanity's ability to organize. And I don't know if that faith is warranted. Yeah, it's a strange one. So yeah, I do always like to put out good information that people can equip themselves with if they find themselves in a conversation with a moon landing denier.
Yep. Which I have been on occasion and probably will again. Where maybe we all have.
Is the Earth flat, or have aliens come to Earth, and did we actually land on the moon? Those are the big three that you're going to encounter, especially when you work in the space biz and people say, "Oh yeah, you do space stuff, right? Well, I'm pretty sure I saw a UFO," and you go, "Okay, yeah, we can talk about that."
Yeah. John has a question for you. He says, Kate, which solar system moon would you actually bet money on being the one where we discover life, be it microscopic or larger?
That's an interesting question. I think I'll answer it as though we had infinite money to send missions to all of the moons. I would probably say Enceladus. However, my optimistic side / the marriage of my optimistic side and my realist side, which says we've got a mission en route to Europa already, so that increases its chances realistically, and hopefully, optimistically, maybe multiple moons have life, and so we're more likely to discover it at Europa because we're going there first. So I'm sort of torn, but I think if I just said which one do I think has signs of life, most likely it would be Enceladus.
Yeah. Adrian comes back and says Voyager is now almost one light day away from us. Indeed it is. In fact, we are about 1 year away from Voyager reaching that milestone, or kilometer stone, is what our boss Bill Nye would probably say. And I sure hope that there's going to be a great celebration of that, which means that things are going to have to turn around some at NASA, because most of the news out of NASA and JPL right now is not great. But that's going to be worth celebrating.
I can promise the Planetary Society will celebrate that.
Yeah, that's what I'm pushing for. And they have actually, I don't want to give anything away. There are people who I will say who are on the Voyager team who would love to have us as a part of that celebration, as we have been a part of past celebrations of Voyager, going all the way back to Carl Sagan on stage with Chuck Berry. You know, after all, Chuck Berry's on the golden record, and we know the aliens in, I don't know, several 100,000 years are going to send back a message, send more Chuck Berry. Let's get to that last moon world that you devote a lot of extra space to. And it's my other favorite, as I said, Titan. So we head back to Saturn. It earns my love in so many ways. As you point out, its surface features are named after locations in The Lord of the Rings and Dune. We are such nerds.
Yes. Oh, yes. I absolutely love that. Yeah. Titan became my favorite moon pretty early on, and has just, like, learning more about it to research for this book just cemented its place at the top, because it's the most alien, like sci-fi type alien world that I've ever come across. I mean, you know, we hear about exoplanets where it like rains diamonds and stuff, but in terms of our local neighborhood, Titan is the stuff of science fiction. It's incredible. Yes, it's the only other body in the solar system that has stable liquids on its surface. It's got rivers and lakes and rain and seas, but it's all liquid methane and ethane, which is mind-boggling on its own.
Crazy
the
stuff.
idea that there's this whole equivalent of like the water cycle. Like I talk about this in the book, you know, you learn in school about evaporation and condensation and precipitation, and then rivers, you know, eroding down mountains and collecting in lakes and then evaporating again. And all that's happening, but with methane, but it's cold enough that it's in its liquid form. That is just so cool on so many levels. And then, yes, of course, the fact that these features are named after just the nerdiest stuff you possibly could. That speaks to my heart. My dog's name is Gimli, son of Gloin. Like,
Kidding.
This is my cup of tea. It's just delightful. And then, yeah, learning about the there's huge fields of dunes of hydrocarbon. So it kind of looks like coffee grounds, and it's basically sand grains, but that aren't formed from erosion. So sand grains on Earth are from bigger things being broken down into tiny grains. But on Titan, it's tiny particles of almost like smoke particles that come together and clump into these grains. So it's just this totally alien kind of sand, basically. And then, yeah, it's got this super thick atmosphere, but the gravity of Titan is low enough that you could conceivably flap wings. Like if you had basically like arm-sized wings, like, you know, you saw back in the olden days when they're trying to learn how to fly on Earth, and there's old-timey videos of people flapping their wings and jumping off hills. If you did that on Titan, you could actually fly, and it's the easiest place in the solar system for flight because of its low gravity and its high atmospheric density. And we're sending a flying spacecraft there, like a gigantic version of Ingenuity with more rotors, and it's going to fly around. It's the coolest stuff. Like, it's hands down the coolest place, and I just love it. And so, yes, I gave it the most space in the book, and it gets the, you know, final big chapter because it's the home run moon, I think.
I am hoping and praying that we will see Dragonfly, that octocopter, launch on time in 2027, because even leaving then, it's not going to reach Titan until 2034. But what an exciting mission.
Yeah, it's going to be so cool. I almost wish it had a little companion spacecraft to take photos of it in flight, because we're just going to have to use our imaginations for that. Yeah. But boy, what a cool mission. What a cool moon.
I know it has a ton of cameras all over it, so hopefully I'm sure they're planning to get some video back from that.
If Perseverance can take a selfie, maybe so can Dragonfly.
So Adrian looked it up and said, yeah, Voyager 1 is the one that's going to reach one light day away in November, in almost exactly 1 year, and that's the one we're going to be celebrating. Dave said, I don't believe in moon landing deniers. I wish I could say that, but I've met too many of them, Dave. So the book doesn't end with Titan. As we said, you've got these honorable mention moons. I want to ask you about your favorites or most intriguing among them. I already mentioned Hyperion. The phobia that I think I really do have a mild case of is called trypophobia, the fear of objects with clusters of holes.
Yeah, I think that's a fairly common phobia. I've encountered a lot of people who have it, and it does not resonate with me. I don't get what's scary about that, but
Lucky
I respect
you.
it.
Yeah, that's
I
good.
like Hyperion. I think it looks really, again, it just looks really cool. It's very different. It brings up all these questions of like, how and why does this moon look like a big sponge? Because it really does. It looks like those sort of like the natural like sea sponges. It just looks like somebody hucked one of those into space and left it there. And I just think that's really neat. And it's like the least dense object in the solar system or something. It's such a cool little world. And I do love Pan, the tiny little dumpling moon that looks like somebody hucked a piece of ravioli out into space. And I love Miranda, the moon of Uranus that has the tallest cliff in the solar system.
Yes. Yeah.
Where the gravity, again, I shouldn't cite things that involve numbers. Read the book and you'll see there are some shocking numbers about if you were to drop a rock off the top of that cliff, it would take a shockingly long time to fall to the ground because the cliff is so huge and the gravity is so low. And it's just neat little things like that again, the numbers don't stick in my brain, but the general idea does, because it's just sort of amazing and cool and worth spreading around.
There is a wonderful old CGI video done a fair number of years ago now, but beautifully done. And it shows humans all over the solar system doing crazy things, like jumping off that cliff on Miranda and floating down to the surface. Man, I won't be in my time, won't be in the time maybe of anyone alive today, but we have quite a future to look forward to across the solar system. David talks about Charon, larger compared to Pluto than our moon is to Earth, just, proportionately. But then he adds, is Pluto a planet? We won't get into that one right now, but Charon is one heck of a moon.
Yeah, I think I actually do talk a little bit in the mini chapter, the honorable mention about Charon, that size difference and the way that they sort of orbit each other instead of one clearly orbiting the other is part of the reason why Pluto is not a planet anymore. It's not considered a planet anymore. So it's part of that whole, some say, controversy of Pluto's demotion.
The center of gravity is not inside Pluto, the center of gravity of the two bodies. And that's one of the reasons it got downgraded. But don't say that to some of our favorite scientists, our favorite planetary scientists.
Yes, I'm actually, sneak preview. I'm working on the March issue of the Planetary Report right now. And we're going to be talking about dwarf planets in one of the features. And something that I always like to say when talking about Pluto being demoted is that it actually just became the most famous of the dwarf planets. It kind of got bumped up to the top of the list in a lot of ways because, now it's sort of the king of the dwarf planets and everybody's favorite dwarf planet. And also by being, I'll use the term demoted regardless, but by being demoted, it brought attention to all the other dwarf planets. And I think that is actually a really valuable thing because, again, like moons, dwarf planets are a really interesting category of world. And there are a lot of interesting things going on out there. And people should not only care about planets. So I'm pro Pluto as a dwarf planet, even though I know that there are lots of people who strongly disagree. And you can come for me in the comments.
You finally, in the book, take us across the light years. We leave the solar system, and you talk about exomoons circling exoplanets, which we now know there are thousands and thousands of them. I think we just hit 5,000 confirmed exoplanets. Pretty much every star has at least one planet, and a whole bunch of moons out there. So we've started to find exomoons as well, right?
Yeah, and this is another thing that just boggles the mind, because when you think about the number of moons in our solar system and the chances that any of them could be habitable, it really, really expands what we, like when we think about what there in other star systems, how many worlds there are that could be home to life, just exponentially increases when you realize that moons could just as easily be home to life as planets. And again, I keep going back to Carl Sagan. I mean, he was just the biggest influence on me ever. And in his day, people didn't know if there were exoplanets. Like they were theorized. They thought that surely there must be planets around other stars, but there wasn't direct confirmation of exoplanets until fairly recently. And now we, like you said, we know that they're out there around pretty much every star. And when you think about, just the implications of those numbers, and then the number of moons compared to the number of planets in a given solar system, it really is basically impossible that life doesn't exist out there, which I think is, like one of the most important and fascinating questions in space science. So exomoons, I think, are something that we're going to learn more and more about over the coming decades as the technological ability to study them advances. Even with new space telescopes coming online in recent years, our ability to study these things is really growing. And I think that that's where a lot of the most interesting science is going to come in the coming years.
I want to meet some of those very tall blue people with tails that live on the exomoon Pandora someday. Let me get to a last round of questions and comments from our wonderful members. And one of them is a dear old friend of mine. Larry is out there. He says, personally, I'm excited about the prospect of liquid water on Europa under all that ice where it would be protected from the Jovian radiation. Fingers crossed, Larry. John says, my Christmas list now includes Kate's book. Thank you, Matt, and thank you, Kate, says John. David, if you don't want to debate about planethood for Pluto, how about Karen versus Sharon as a pronunciation for that moon of Pluto? Good one, Dave. You're right. The other Dave says, if our moon is the same size of Earth, which one would be considered the moon? If our moon was the same size as Earth, would they be a double planet, a double dwarf planet, or a twin moon? Not being a planetary scientist, Dave, I think I will leave that to our betters who actually have that expertise. But wouldn't that be interesting?
One thing I will say on that note is that the Earth's moon is not nearly as large as Earth, but it is the biggest. It has the biggest size ratio. So there aren't any planets in our solar system that have a moon as big relative to the planet as Earth's moon is to Earth. So it's as close as you really get to a full-blown planet having a big moon. I guess, unless you considered Pluto a planet, but we're not getting back into that debate.
So that's a win for the Earth-Moon system. Adrian looked into it or knew that actually if you had two worlds roughly the same size orbiting about each other, it's called a binary planetary system, a binary planetary system. Makes sense, right? Okay. I want to get back to your life outside of writing books and doing all this great work for the Society, because you are a proud Canadian. Sorry about the Blue Jays. I really genuinely am sorry about that. I was kind of pulling for them at the end, even though I'm an old Dodger fan. But just the same, you guys have so much to be proud of up there. You've had a little bit to do with the Canadian space program over the years. Can you talk about that?
Yes. So I was actually first hired to the Planetary Society to be a liaison into the Canadian space community. My role has shifted over the years. It's been about 12 years now since I was first hired. But yeah, my earlier part of my career was really deeply involved in the Canadian space community. We have a really strong space community here. It's a small space program, especially relative to NASA, but we punch above our weight, I would say. Yes. And for a period, the Trudeau government introduced a space advisory board, which brought on experts from across different parts of the space sector to advise the government on what direction our space program should go in. And what changes needed to be made on various levels. And I had the enormous honor of being on that board. And so I got to help people with a great deal more experience than me kind of guide the space program for a few years. That board sort of wrapped up its work a few years ago, but that was a really amazing experience, and getting to really feel that the Canadian government values the perspective of the space community, whether that's policy, science, engineering, law. I was mostly on the board as a representative of the sort of education and outreach side of things, but really seeing the government take all of these perspectives seriously to adjust the trajectory of the space program was really special. And since then, I'm still very involved. I work with the Canadian branch of the Students for the Exploration and Development of Space, SEDS. So SEDS exists in the US, and we have SEDS Canada as well. And I'm involved with another fellowship program for young people getting involved in the space community called the Zenith Pathways Fellowship Program. I really, really do enjoy getting the opportunity to meet young people who are so passionate and so interested and want to contribute to Canada's space program. We also, I think, could benefit from more funding. I mean, the US is dealing with this threat to what has been ample funding. I would say compared to the rest of the world, NASA has been extremely well funded. And I think countries like Canada haven't had the benefit of huge budgets. So I think there was so much more that we could do. Like Canada has never run its own independent planetary exploration mission. That being said, we've contributed to many, many international partnerships with NASA, with the European Space Agency and others to contribute instruments or pieces, or the famous Canadarm, for example, on the shuttle and the International Space Station, but also instruments on scientific missions. And I think that's something that allows Canada to have an important role in exploration and also give our students and our scientists opportunities to participate in like the forefront of space science research. But I would love to see Canada have our own independent planetary exploration mission someday. And I think that's very possible with the talent and expertise that we have across the country.
Is it the $5 Canadian bill that has the Canadarm on it?
Yes, that just came out a few years ago. And it's so special because, Canada's money, Americans love to make fun of our money because it's different colors and it has animals on it and whatnot. And we have the loonie and all that. But really, I think Canada's currency does a good job of celebrating things that Canadians are proud of. And the $5 bill has the Canadarm and an astronaut, because Canada also has a strong astronaut program. We've been sending astronauts on shuttle and ISS missions for years. And we have an astronaut who will be flying on the Artemis 2 mission in the vicinity of the moon and come back to Earth, Jeremy Hansen, who's actually spoken at a Planetary Society event before.
At the University of Toronto, right? When we did our big event up there. Yeah.
Yes. So, Canada does have a lot going on, and I've always been proud of our program, and it is good to see that the government recognizes that Canadians are very proud of what we do in space.
Any nation that puts space technology on its money has got to be awesome.
Yes.
And I think across this last little bit more than an hour, you've seen plenty of evidence of Kate's awesomeness and why we are so glad to have her as a part of our staff, our mighty staff at the Planetary Society. But the book club is just going to keep trucking on in this grand tradition, which we have continued today with Kate Howells and her book, Moons, The Mysteries and Marvels of the Solar System. Kate, thank you so much for the book and for all you do for us and for spending this time with us this evening.
Thanks, Matt. Thanks, everybody.
Moons, The Mysteries and Marvels of Our Solar System is published by Lost the Plot. Yes, Lost the Plot. And you can find it in all the usual places. It's a delight, as is Kate Howells. And so is Adam Frank. He'll be my next guest author here on the Book Club edition when we talk about Adam's latest, The Little Book of Aliens. Planetary Radio is a production of the Planetary Society. Our associate producers are Ray Paletta and Mark Hilverda. Post-production is by Andrew Lucas. The Society's member community is led by Amber Trujillo. The producer and host of Planetary Radio is Sarah Al-Ahmed. I'm Mat Kaplan, Ad Astra.